Hi everybody, today's lesson is R.5 day 2. This is Rational Expressions Continued, and today what we're going to do is talk a lot about LCD, if you remember that from probably several years ago in math class, least common denominator. And we're going to be adding and subtracting fractions, so keep in mind yesterday what we did was we multiplied and divided, and the purpose of that, or the goal of that, was to factor everything and cancel as much as you can. So you know how when you add and subtract fractions you need a common denominator. So that's why we're going to be talking a lot today about LCD. And I really want to start off, I'm not going to lie, this is a really difficult section and a tough chapter for adding and subtracting rational expressions. So I'm going to do this really basic example here, this one, just to kind of refresh our memory. So you know how if you're adding fractions you have to have a common denominator. And so what a lot of people would do is maybe change the first fraction into something over 9, and then keep the second fraction 1 over 9, so that you have a common denominator, because you know how when you add fractions you have to have the same denominator in order to combine them. And then you just keep the denominator and you combine everything on the top. So what we have to do is figure out how to turn 2/3 into something over 9. And so what we did to get the 9 in the denominator is we multiplied the bottom by 3. And whatever you do to the bottom, you have to do to the top. So that 2 over 3 is going to turn into 6 over 9. And so now that they have the same denominator, this is 9, this is 9, my denominator stays 9, and I'm just going to add the top. 6 plus 1 is 7. And then reduce that fraction if you can. 7 over 9 does not reduce, so we're finished. Okay, another thing that I want to kind of refer to in terms of this problem is that maybe some of you were thinking of doing a different denominator. And a really common strategy for finding a common denominator is to just multiply the two denominators together and get 27. Maybe some of you were thinking about that, so I'm going to show you another way to do that. What if I changed both of those fractions into something over 27? Would I still get the same answer? Is that still okay? Can I still do it like that? And so what you're going to do to change the 3 into 27 is multiply by 9, right? So you also have to multiply the 2 by 9, and therefore you get 18. And then I'm going to do the same exact thing to the 9. I have to multiply this 9 by something to get 27, and so I'm multiplying it by 3, which means I also need to multiply the top by 3. So I get 3 over 27 in that case. And here we go again. Now we have the same denominator, and that's what we want to add fractions, and then we're just going to add across the top. 18 plus 3 is 21. And then remember how I said you're always supposed to reduce if possible? So you know that those both divide by 3, and so we end up with 7 over 9. Okay, so my question to you is, what is the difference between this one and this one? This was a little bit more work. It took a little bit longer for us to do, but we got an answer of 7 over 9. And what did we have to do once we were finished? We had to reduce it. In this one, we didn't reduce because we picked the least common denominator. Okay, so either way, whichever way you're more comfortable with is fine, and you might think of a different common denominator than somebody else, but hopefully if all the fractions are reduced at the very end, you'll all have the same kind of answer. Okay, so that was kind of a long explanation of some really basic fraction work, but that's what we're going to be doing with all of these problems now that have x's in them. So what I'm going to do is kind of skip around a little bit. We're going to do these 5, and then the 2 on the back I'm going to save for class tomorrow, okay? So I'm going to skip around, and I'm going to start down here with this one over x plus 5. So what I want you to notice about this one is that we need to add the fractions, and when we add fractions we have to have the same denominator. Well, these do have the same denominator, so this one is supposed to be a really easy example, which is why I'm picking it first. Okay, we just keep the denominator on the bottom, and then all you have to do is combine everything on the top. Okay, so when I combine everything on the top, you could probably do this without writing it all out, but I'm actually going to write 2x plus 5 plus 3x plus 20, just to emphasize the fact that you're just combining everything on the top and keeping the denominator. So that means we end up with 5x plus 25 over x plus 5. And that's because I combined 2x and 3x, and I combined 5 and 20. Again, we're not multiplying here. That's what we did yesterday. This is addition. So that's why we're just adding the terms together. Okay, and we're done. Just kidding. Why are we not done? Take a look at the problem real quick. what we can do here is you notice that there's a GCF in the top. Did you notice that? And so when I take out that GCF in the top, I get x plus 5 over x plus 5. So do you notice here that this will cancel? So you're always supposed to reduce if possible. This entire problem just turned into 5. Okay, so beware of that. At the very end of the problem, when you think you're done, you should always check to see if anything reduces, because most likely you'll be able to factor something and it might cancel. Okay, now I want to go up to this one. Like I said, we're going to skip around a little bit. You notice that these denominators are not the same, and it's kind of like what we talked about yesterday, where I can change this fraction by taking out a -1, and then my x is going to change into positive and my 2 is going to change to negative. So that is a way that I'm going to write this denominator. And then what I'm going to do is this negative sign, I'm actually going to kind of bring it up to the top. Okay, so what's going to happen here is that negative sign is going to come up on the 4 so that my denominators are the same. So I haven't done anything to the fraction, but I'm going to bring that negative sign, this one, up on the 4 so that my denominators are the same. Okay, so now I have the same denominator. And on the top, I'm just going to combine everything, 3x plus -4, which is the same as 3x minus 4. Quick check to see if there's any GCFs or any canceling that we can do, and there is no GCF in the top, so there's nothing I can factor out. Nothing will cancel. This is my final answer. So a little bit of a trick for that subtraction binomial problem. If they're backwards, basically you take out a negative sign, and then the denominators are the same. And that's really similar to this one down here. So notice again that we have the denominators that are different. And so basically what I'm going to do, it's kind of a shortcut for the reason that I just explained. I'm going to reverse this. And I'm going to change this to a negative. Which, yeah, actually that means that we are going to end up adding this. Okay, so basically I just took that negative out and slid it up to the top on the 2, and then I had a double negative, which means I can change it to a plus. My denominator is x minus 6 because it's common for both. And on the top, I'm just doing 3 plus 2, which is 5. Nothing cancels here, nothing simplifies, we are done. So those are supposed to be a little bit of easier problems. Okay, now we've got 2 more, a little bit harder ones left. The one I want to focus on now, just to try and keep you on your toes, we are bouncing around for this, is this one. So I got to come up with a common denominator here for 9x squared and for 6x. So this is actually really similar to the fraction problems that we did at the very beginning, like these basic ones, is that think about 9 and 6. You could do something like this and actually come up with the least common denominator, which would probably be better and easier and faster. Or you could just multiply 9 and 6 together and use 54. You will have to reduce at the end if you want to use 54. So either way, whichever way you were thinking of is fine. I am going to go the least common denominator route. And so even though we could use 54, I know that there's a smaller number that both 9 and 6 go into. And that number is 18. So I'm just going to get that kind of set up. That means that in order to multiply 9 by something to get 18, this fraction needs a 2 top and bottom. And the fraction on the right is going to need to be multiplied by 3 top and bottom in order to make 18. And I've kind of ignored the x for a second. So here's the way that I like to explain the x. This fraction has 2 x's in the denominator. This one only has 1. And so what we need to do is make them equal. And so yes, you could multiply x squared and x together and use x to the third. But I like to think about it in terms of candy. Think about the exponents as candy. This x has 2 pieces of candy. This x only has 1. And so in order to make them equal, what's the easiest thing for you to do? That would just be to give this fraction 1 more piece of candy. And so the way that I like to think about it there is that I need to multiply this fraction by x and x so that they both have an x squared in the denominator. Okay, again, you could take x squared and x and multiply them together and use x to the third, but you'll have to reduce at the end. We're trying to do least common denominator here. You're just trying to make the denominators match. That's it. Okay, so now what we have to do is just a little bit of cleaning up. I have 18x squared here in the bottom, which is good. I also have 18x squared here, so I need to clean up the top. 2 times 5 is 10, and on this side 3 times 1 times x is 3x. The denominators are the same, so I'm going to keep the 18x squared in the bottom, and I'm going to combine everything here on the top, just being really careful that 10 and 3x are not like terms, so you can't combine it and make 13x. Think back to what you know about algebra. We just have 3x plus 10. And again, there's nothing that factors out of this numerator, so I cannot reduce the 3 and the 18. Only if I pulled out a 3 would I be able to cancel that. This 3x is stuck together with the 10, and so we are finished with this problem. There's no GCF, there's nothing to factor and cancel. We are done. So that was a little bit of a harder example here. We're going to go to the first one, which is actually the most complex. This guy that we've been skipping for this whole time, okay? What we're going to do is, I noticed that there's GCFs in the denominator, so I'm going to factor those out. Factoring the denominators will help you get a better idea of what kind of LCD you need to have. So I'm just keeping the numerators the same, but I'm factoring out GCFs from the denominators. Okay, so now I need to think about what my LCD is going to be, least common denominator. And so that's the reason why we did that other one first, is that if you look at just the x's, there's one x here and there's two x's here. So in order to make them equal, I need to make this one have another x. So that's the first thing that I need. And then another weird thing is that this fraction has an x minus 3 and this fraction needs an x plus 3. And the goal here is to make them match. So this one needs an entire factor of x plus 3. And this one needs an entire factor of x minus 3. And since I'm multiplying that entire right-hand fraction by x minus 3, I'm going to put parentheses around this as well to remind myself to FOIL. Because I'm not just multiplying the 2 by x minus 3, I'm multiplying the entire fraction. So now let's do a check and look at our least common denominator here. I have two x's, x minus 3, x plus 3. On the right side I have two x's, x minus 3, x plus 3. So now they have the same exact denominator, which is good. So I'm going to clean it up a little bit, and I'm going to write it as x squared, x minus 3, x plus 3. And the other one, x squared, x minus 3, x plus 3. And now we have some simplifying and stuff to do. So I'm going to first multiply my 4x together, and then I'm going to have to distribute it to the x plus 3. So this is what the first fraction looks like. The second fraction here, this means FOIL. Okay, so foiling in my head, x squared minus 3x plus 2x is going to give me a negative 1x, and then negative 6. So we are almost done simplifying this one. What I'm going to do now is distribute my 4x squared, and then I'm going to write this all as one fraction so that I can combine all my like terms. They have the same denominator, even though it's a really big, long denominator, they are the same. So I'm going to copy them back down. And I'm going to distribute my 4x on the left, so that makes 4x squared plus 12x. Keep the plus sign, and then the other fraction I have x squared minus x minus 6. Keep the denominator. Again, it's a lot of writing of the denominator, I know. But we're just going to combine like terms on the top. 4x squared plus x squared gives me 5x squared. 12x minus x gives me positive 11x, and then I have a negative 6. Okay, so this is a long problem. There's a lot of writing and stuff that we need to do. However, there's one last thing I should do, and let's check and see if the top factors, because maybe we'll be able to cancel some factors like we talked about in class yesterday. Okay, so what I'm going to do is, one of the tricks to factoring is take the 5 and the negative 6 and multiply them together. That gives you negative 30. And they need to add up to 11. So it needs to multiply to negative 30, it needs to add up to 11. So I got to think of two numbers. So the factors of 30 are 6 and 5, 3 and 10, 15 and 2. And do any of those combinations make 11? And you might be thinking 6 and 5, but think about it. It has to multiply to negative 30, which means one of them needs to be negative, but they have to add up to positive 11. And there's no way to make negative 30 and positive 11 using 6 and 5. Okay, so that tells me that this part doesn't factor. I'm going to write that. Doesn't factor. So that means we are done, but I want you to have that written down in your notes because you always need to check it, because a lot of times, you guys, something will factor. Just beware about that, okay? That's it. We're going to save the next two in the notes packet to do in class together tomorrow. Make sure you bring your questions. I'll see you later.